are going to go over section 8.5, scientific notation. So make sure you get your books out and you're on page 469 of your textbooks. Let's take a look at the very top of page 469 and read that together. It says, what was the price of Alaska per square mile? I don't know if you've been studying this in history or not, but this is kind of interesting. It says, in 1867, the United States purchased Alaska by writing a check for $7.2 million. In example 5, we're going to use scientific notation to find the price per square mile of that purchase. As you might remember, in a recent class, you guys noticed that your calculators were returning a weird number where there was an E at the end and then another number, and we discussed how that E was a form of scientific notation, the way that your calculators handle it, and it was really, it meant times 10 to whatever number was after the E, to show you that, in scientific notation. So basically, up to this point, you've been dealing with numbers primarily. I guess you've also had numbers in fraction form, but specifically, you've had numbers that were in decimal form. And those, of course, you've seen those numbers. They're any kind of number like 100. I'm looking in the book here, 14.2. Or 0.07. These are written in decimal form, okay? But any of these numbers, if we wanted to, we could write them in scientific notation. And basically, the format is this. And I guess I have the word up there anyway, scientific notation. So the format is this. You're going to have some number that's going to be... it's going to have one decimal place to the left of the decimal, and then it might have a few other decimal places here. It depends on how far you want to carry the decimal. And it's going to be times 10 to some exponent of 10. And they, the way that they have in the definition, they say that the number is written in scientific notation if it is of the form C times 10 to the nth power. So, that can be any exponent. That could be a positive exponent or a negative exponent. It's a positive exponent when we're talking about a very large number, and a negative exponent when we're talking about a tiny number. But this number right here, they wrote it down as 1 is less than or equal to C, which is less than 10. So notice it's never equal to 10 because there's only one decimal place here. It would have been better if more clear if they just said less than or equal to 9. Okay, so it's a number. It's going to be a digit between 1 and 9 sitting in this spot, and it's going to be times 10 to some power. All right, now let me clear this. All right, so let's take a look at, okay, well, here they're showing you 1.2 here. 1.2 times 10 to the third power, okay? So this means that this number is going to be larger than what you see here. And so we write 1.2, and then this is if we're converting it over to decimal, and we're going to move the decimal place 3 places to the right. So 1, 2, okay, so this is going 1, 2, 3. So in other words, this number, 1.2 times 10 to the third power, is the same thing as 1,200, okay? Because what is 10 to the third power? That's really 1,000, right? So if you take 1.2 and you multiply it to 1,000, you're going to get 1,200. All right, 5.6 times 10 to the first power, 10 to the 0 power, I guess I should say. Well, what is anything times the 0 power? That's another way, that's a fancy way of just saying 1, right? So what is this equal to? Well, 5.6 times 1 is 5.6. Nothing changes there. The decimal place, in other words, moves nowhere. It just stays put. And then 3.5 times 10 to the negative 1 power. So since this has a negative exponent, that means our number is going to get smaller. And so we're going to move the decimal. Okay, since this is left, we're going to move it to the left one. And so our number becomes this. Because this is really like saying 3 times 5 times 1 over 10 to the first power, right? Which is like 1/10. So this is really like saying 3.5 times 0.1, which gives us this. All right, so let's do example 1. All right, example 1. says write the number in decimal form. So they're going to give us the number in scientific notation, and then you guys are going to write it in decimal form. So they're giving us 2.83 times 10 to the first. This is in scientific notation. I only have one digit here to the left of the decimal. Okay, this is like multiplying it by 10, right? So what's going to happen to my decimal? And this is a positive exponent. So this is going to move to the right. That decimal point is going to move one to the right. So this ends up being 28.3 when you convert it from scientific notation to decimal. All right, now you got 4.9 times 10 to the fifth. Okay, so this is, this is a big number. It's like saying 10,000, right? It's going to be 1 with 5 zeros. That's the same thing as, that's 100,000. Yeah, that's actually 100,000. 1, 2, 3, 4, 5. Yeah. All right, so what is that? Okay, well, I'm going to take the decimal, and it's going to move to the right 5 times. So it's 4, okay, 9 here. So it's going to move to the decimal from here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, our decimal's here now. So what is this number? It's 490,000. Okay, and now C, we have 8 times 10 to the negative 1 equals 0.8. Okay, oh yeah, okay, well, it's because my decimal place is here. I'm going to move once to the left, right? So it was here, and it's going to move over here, so it's 0.8. And then lastly, D, we've got 1.23 times 10 to the negative third. All right, so that means our number is going to be smaller, means our decimal place is going to move to the left 3. So we're going to move this 1, and then we got 2 more zeros. So this is going to end up equaling 0.00123. The decimal place was originally here, and now it's moving 3 places to the left, so there it is now. Okay, what I'd like you to do is go ahead and do the checkpoint, and in the next video, you can check your checkpoint.